In this video, we are going to talk about the nomenclature of aldehydes and ketones. In other words, how to name aldehydes and ketones. First, what is the difference between an aldehyde and a ketone? Now, anytime you see a carbon that is doubly bonded to an oxygen, it is called carbonyl in organic chemistry. So aldehydes look like this. Always the carbonyl has a proton bonded to it, and then the other part is hydrocarbons. And then a ketone has a carbonyl bonded to a hydrocarbon on one side and another hydrocarbon on the other side. So that is the difference between aldehydes and ketones. So let's start with the naming of aldehydes. So let's assume we have this kind of compound. So how do we name this compound? Now, if you look at this compound, the first thing we need to do is to identify the parent chain. Now, the parent chain must contain the carbonyl functional group. So we start the counting from the carbonyl functional group. So starting from here, it becomes 1, 2, 3, 4, and 5. If we go the other way to is 1, 2, 3, 4, 5, or the other way to 1, 2, 3, 4, 5. So in this case, the parent chain contains 5 carbons. And because it is a 5 carbon, we are talking about pentane. Now, for aldehydes, the parent chain will end with, you remove the E in the parent chain and add Al. So in this case, it becomes a pentanyl. And for ketones, you remove the E and then add O-N-E. So in this case, if it was a ketone, it would have been a pentanone. So let's come back. However, we see that there are two methyl substituents on carbon number 1, 2, 3, 4. So on carbon number 4, so we have 4,4-dimethyl. And then the pentanyl. So that is the name of this aldehyde. So let's consider this aldehyde too. What will be the name of this aldehyde? So first, let's determine the parent chain. So this carbon number 1, carbon number 2, and carbon number 3. So it is a propane. And because it's an aldehyde, then we are talking about, propanol. So the name will end with a propanol. But we have a substituent, a methyl substituent on carbon number 2. So we have a 2-methyl. So this becomes 2-methyl propanol. Let's consider this other compound. You see that this compound is different from the ones that we've named because this one contains 2 aldehydes. So what we do is that we start from the aldehyde that gives us the least number of carbons, but both are terminal aldehydes. So therefore, anywhere we start does not matter in this case. So if we start from here, this is 1, 2, 3, 4, and 5. So we have a parent chain of 5 carbons. But we need to state the positions of the carbonyl compound. The carbonyl carbon. And in this case, we have one on carbon number 1 and carbon number 5. So this is a pentane. So we can name it as pentan. Then we state the position of the aldehyde. So this becomes pentan 1, 5. But there are 2, which is a di. And then we said the name has end with Al. So dial. So this becomes pentan 1,5-dial. So let's consider this case. You see that in this case, we have 2 functional groups. We have an OH functional group, and then we have the aldehyde functional group. Anytime an alcohol is acting as a substituent, then it is named as hydroxy. But there are 2. But let's name the carbons. This is carbon number 1, carbon number 2, and carbon number 3. So we have 1 hydroxy on carbon number 2 and the other on carbon number 3. So this is a 2,3-dihydroxy. but the carbons are number 3 carbons. So we are talking about a propanal. So propanal. So that is the name of that molecule. So let's consider this other case. So just as what we did first, you see that there's an OH group here. So that will act as a substituent. Let's label the carbons. This is 1, 2, 3, 4, and 5. So the OH is on carbon number 5, and that is 5-hydroxy. But there are 5 carbons, so we are talking about pentanal. So 5-hydroxy pentanal. Now let's talk about this case too. The difference is that in this case, you can see that we have a 5-member cyclic ring, which is attached to the aldehyde functional group. Anytime you encounter a situation like this, then you name the cyclic ring different, and then the carbonyl functional group, you add carbaldehyde. So in this case, the name is supposed to end with a carbaldehyde. But this 5-member cyclic ring is cyclopentane. So this is a cyclopentane, then carbaldehyde. So cyclopentane, then carbaldehyde. So that is the name of this molecule. Now let's consider this other case. It looks similar to the previous case we did. So you see that the aldehyde functional group is out of the cyclic ring. So the name is supposed to end with a carbaldehyde. But we have an OH, which is a hydroxy functional group on carbon number 4. If we start from here, this is 1, 2, 3, and then carbon number 4. However, this is the chair conformer. So that means we need to determine the stereochemistry between these two functional groups. And we are talking about this is in the equatorial position, and this is also in the equatorial position. And we are talking about the case of 1,4. So EE is a trans, and therefore the name will proceed with trans 4-hydroxy cyclohexane carbaldehyde. So let's consider this molecule. You see that this is a benzene group attached to an aldehyde functional group. So in the previous case, we would have named this as a carbaldehyde. However, because this is a benzene, this is known as a benzaldehyde. So let's consider this molecule. How will we name this molecule? So you see that from here to here is a benzaldehyde, and then we have an OH group on carbon number 4. But this is in the para position. This actually is an aromatic compound. Later on, we will talk about the aromatic compounds. So this is on the para position. So p-hydroxy benzaldehyde. So let me rewrite the name well. So this is p-hydroxy. So let's consider these two molecules and name them. Now, if we check this, let's determine the parent chain. So you see that there are 4 carbons. However, you can see that there is a benzene group, but this benzene group is not part of the parent chain. So it is a substituent. Anytime benzene is a substituent, it is referred to as a phenyl. So let's number the parent chain. So here's 1, 2, 3, and then 4. But we could have also gone the other way around, which is 1, 2, 3, 4. However, the one we did previously is the ideal one, because you see that for that one, the substituent is on carbon number 2. But for the top one, the substituent will be on carbon number 3. 2 is smaller than 3. We always have to do the numbering such that the substituents are on the least number of carbons, and therefore we have a 2-phenyl. and then the parent chain is 4 carbons, so it's a butane. So the name will become 2-phenyl butane, but they are two, so dial. So let's come to this case. You see that we can see an alkene functional group here, but let's consider the parent chain and number it. So here becomes 1, 2, 3, 4, 5, and then 6. So we are talking about the case of a hexane. However, because of this alkene functional group, we cannot say it is a hexane, but however, we must say it is a hexane. Anytime you see En in the parent chain, then you know that that parent chain contains an alkene functional group. So this becomes, but the alkene functional group is on carbon number 5. So we have a 5-hexane. So this becomes 5-hexane now. So let's come to the case of ketones. Let's consider this and name this. So the first thing is to identify the parent chain. But if you notice, you see that for the aldehydes, because always the aldehyde functional group is a terminal functional group, we didn't consider the position of the functional group itself. But for the ketone, it could appear anywhere, and therefore the position of the carbonyl carbon is very important. So let's number this. So here becomes 1, 2, 3, 4, 5, and 6. But if we start from the other side, here is 1, 2, 3, 4. But you see that 3 is less than 4. So we must always ensure that we get the functional group or the substituent on the least number of carbons. So we are talking about the case of a hexane, but the carbonyl carbon is on carbon number 3. So this is 3-hexanone. Let's come here. This is 1, 2, 3, 4, and then 5. So this is the case of 2-pentanone, but we have a functional group on carbon number 4. So a 4-methyl, and then 2-pentanone. So that is the name of this functional group. See that with this is a cyclohexane, but we have a 4-methyl. So this is 1, 2, 3, and 4. So 4-methyl. And then the carbonyl carbon is on carbon number 1. So in this case, this is 4-methyl, and then cyclohexanone. So let's consider this other molecule and name it. So let's determine the parent chain. So here's 1, 2, 3, 4, and then 5. So we are talking about the case of pentanone, but the carbonyl carbon is on carbon number 2, so it's 2-pentanone. Nonetheless, we have a substituent, methyl substituent on carbon number 4, so we have a 4-methyl. And just as we did for the aldehydes, you see that there is an alkene functional group on carbon number 3. So instead of a pentanone, this becomes a pentanone. The one is on carbon number 2, so pentan-2-one. So we have a 4-methyl, and therefore the name becomes 4-methyl. Alkene functional group is on carbon number 3, so 3-pentan-2-one. So this is the name of that molecule. So let's name this molecule. You see that when we consider this molecule contains both a ketone and then an aldehyde. The rule says that if there is a ketone and aldehyde functional group on the same molecule, precedence must be given to the aldehyde, and therefore this will end with an al and not an on. So let's label the parent chain. So this becomes 1, 2, 3, 4, and then 5. But then we see that we have a substituent, that is a methyl group on carbon number 2. So we have a 2-methyl. Then the other part of the molecule, which is the carbonyl carbon, that makes up the ketone. That substituent is named as an oxo, and it falls on carbon number 4. So we have a 4-oxo. And we are talking about the case of 5 carbons. So this is a pentanal. And therefore, this is, but M and O, M comes before O. So a 2-methyl first, then 4-oxo pentanal. So let's solve these problems. It says that we should write the structural formula for each of the following. The first one is 2,2-dimethyl propanal. So 2,2-dimethyl propanal. The way to do this is to first start with the parent chain. So with the parent chain, we are talking about a propanal. So let's draw a propanal. So 1, 2, 3. So let me put the carbonyl carbon here and then a proton here. So 1, 2, 3. This is a propanal. Then we have a dimethyl on carbon number 2. So 2,2-dimethyl. So 1, 2. So 2,2-dimethyl propanal. So that is how this molecule will look like. And then the B part says 2-propanal. Now, because of this E, we can know that there is an alkene functional group in this molecule, and the alkene is on carbon number 2. So let's first draw a propanal. So let's draw the one we drew initially. So 1, 2, 3. This is a propanal. And then we have an alkene functional group on carbon number 2. So this is 1, 2. So the alkene functional group is supposed to be here. So the first one is 2. The first one is 2,2-dimethyl propanal. And then the second one is a 2-propanal. Then we have the C part, which is 2,3-butane-dione. So because of this dione, we are talking about 2 ketone functional groups on the same molecule. So let's first draw a butane. That is 4 carbons. But it's on carbon number 2 and carbon number 3. So if we start from here, 1, 2. So we have a carbonyl functional group here. And then 3, another carbonyl functional group here. And that is all. So this is 2,3-butane-dione. Then the last one, which is 5-isopropyl 2-methyl 2-pentanone. Please, the D part was a mistake. This is the proper molecule that we are supposed to draw. So it is 5-isopropenyl 2-methyl 2-cyclohexanone. So let's start with the parent chain. So cyclohexanone, we need to first draw a cyclohexanone. So this is a cyclohexanone, but they are saying 2-cyclohexane. Because of this, it means that there is an alkene functional group, but that alkene functional group is on carbon number 2. So this is carbon number 1, carbon number 2, number 3, number 4, 5, and then 6. So the alkene functional group is here. Then we also have a 2-methyl substituent. So this is the 2-methyl substituent. And then we have this, which is the 5-isopropanal. Now, this is the structure of an isopropyl. But because it is an isopropanal, it means it also has an alkene functional group. And therefore, this must bear an alkene functional group, which must be on carbon number 5. So this is how it looks like. So let me redraw the molecule. So the final molecule is going to look like this. So this is the structure of 5-isopropenyl 2-methyl 2-cyclohexanone.